Welcome! I'm going to show you how to do monthly compound interest, vectors, length of aligned segments, Venn diagrams, interpreting set notation, dependent events and probability, harder trigonometry, and sketching Trig graphs. I'm showing you all in this Cambridge February-March 2023 paper 42. Let's go. Right, let's get going with question 1. Elaine and Beatrice shares $750. In the ratio 8:7, show that Elaine receives $400. Oh, it's actually give us the answer. So let's see. If Elaine gets $8, Beatrice will get $7, right? And we add that together. That means we're only sharing $15. Whereas we actually got $750 to share. So we need to keep sharing, keep giving Elaine 8, keep giving Beatrice 7 over and over again until we've shared out 750. So how many times are we going to have to do that? So we do 750 divided by 15. Where is that calculator? There we go. 750 divided by 15. 50 times. So 50 times we need to keep giving Elaine $8. So 8 times 15 is what? Oh, that's 400. And 50 times we need to give Beatrice $7. Well, that would be 350. So there you go. Elaine gets 400. So the calculation really over here was, what was it? 8 times 50. Is $400. So what they know that you know the answer is 400. They really just want to see this calculation in that form. So they want to see 8 plus 7, done it there, and then you divide the answer into 750 and then multiply by 8 and you get 1 mark. Right, part 2. Write 150 as a percentage of 400. That is just a fraction. Percentages are fractions out of 100. Okay, so first we write it as a fraction, 150 out of 400. Okay, I mean 150 out of 400. See? That is the decimal value, and if you want the percentage, you just times it by 100. So that's times 100 equals 37.5%. Remember, percentages is just fractions out of 100. There we go, we got it right. Invest the remaining $250 at a rate of 2% per year simple interest. Calculate the amount Elaine has at the end of 5 years. Here we're getting into interest. Okay, I think we need to stop here and look. Yeah, we remember there are 2 forms of interest. There is simple, which nobody really uses. Anyway, simple's got this formula. The interest, very important, equals the principal, that is the amount of money you start off with, times the rate, that's the percentage interest, times the time, divided by 100. Okay. Remember that. Opposed to compound, which is the amount. This is important. Simple interest gives you the I, which is interest. Compound gives you the amount, which is the total amount of the money. Okay, remember that. Anyway, that is the P, the principal, again, the money you start off with. Then you get a multiplier, which is 1 plus the rate divided by 100. That just gives you a multiplier like 1 point something something to the power of the time. Okay, so of course we're going to use the simple interest formula. So to get the interest, which is only the extra money she earns, we take the principal, the P, this is the P, the money you start off with, $250, times the rate, which is 2, times the time, which is 5, and you divide it by 100. Okay, so let's put that in. So it will be 250 times 2 times 5 divided by 100. $25. Okay. So does Elaine have $25 in the bank after 5 years? No, that would be stupid because you put 250 in, because this formula will give you the interest, only the extra money you earn. So if you want to know how much money you have in the bank, of course you need to add it. You get $275. It's not a lot, but it's correct. Okay. See, 1 mark for using the formula, and then adding it on to 250 gives you the second mark. Easy marks here, yeah? You understand what that means? 1 mark for using this formula, 1 mark then for adding it to get the total amount. Okay, always think, does it make sense? $25 after 5 years? No. Right, because now we got Beatrice who invest $350 at a rate of 0.25% per month. You see, month is in bold. So it slaps you in the face. You need to say, why is this in bold? There's a reason. It's a booby trap. It's something that is different from what it usually is. Okay, compound interest. Okay, so we know we're going to use this formula. A equals P1 plus R over 100. Okay, just wrote it again. Okay. This gives you the total amount Beatrice will have at the end of 5 years. Okay, so what are we going to do? We're going to start with the principal, P, the money she started off with, 350. 1 plus the rate, 0.25 out of 100. And then, do we put 5 there? No. We don't put 5 there. We don't. Because that highlight there, that month, that is in bold. We need to be careful, okay? If anything is in bold, you know, you just go carefully. Okay. Because this will be calculated monthly, not yearly. So every month they add 0.25% to the amount she has in the bank, which is compounds. So how many times a year are they going to calculate that? That is 12 calculations a year. Alright? Every month calculated 12 calculations. And then they're going to keep doing that for 5 years. So that means that is 60 calculations. So it's to the power of 60. So the time in this case is 60 months, not 5 years, because the rate is given us a monthly rate. So this is where this booby trap is, yeah? Okay, so let's put that in the calculator. Bam, 406.565. Etc. And this is now where you always have to reread the question carefully. Give your answer correct to the nearest dollar. Okay, so that means that's going to count the mark. Nearest dollar is like the nearest whole number, which is 406. We need to cut it off there. But because there's a 5 next to the 6, we need to round it up. 407. Okay, so looking at the mark scheme, 407, you don't have to put the zeros. Correct answer only. CAO means so there's no other answer you could possibly put there. Not from wrong workings, I mean if you don't have the right calculations there, you don't get your marks. Alright. And there we go. See? In fact, you see that they say here, some forgot to give their answer to the nearest dollar. So it's a simple thing, but students forget to do that. Okay, it says it in the examiner's report. Okay, so you lose a mark if you don't write 407. Right, now question B, we've got Carl, Dina and Eva share 100 oranges. It's a weird thing to do, but anyway. The ratio Carl's oranges to Dina's oranges is 3 to 5. The ratio Carl's oranges to Eva's oranges is 2 to 3. Find the number of oranges Carl receives. Oh my goodness. Let's just write all those working in something here. We got Carl and Dina. The ratio is 3 to 5. Then we got Carl and Eva. The ratio is 2 to 3. What's the common thread here? Carl. Carl is the common thread. So what I'm going to do is I am going to put Eva into this ratio. Okay, so we can put it here. Eva's ratio is 3. But when Eva's ratio is 3, Carl's ratio is 2. You see? So Eva's ratio to Carl's ratio is 3 to 2. Carl's ratio to Dina's ratio is 3 to 5. Okay, what we can do now, we can get the common multiple of 3 and 2. Alright, let's change color. Alright, so if I multiply this ratio by 2, and I multiply this ratio by 3, which we can do, equivalent ratios, we multiply both, it's like simplifying ratios, we multiply both of the ratios by the same number, the ratio stays the same. So that makes Carl's ratio both 6, Dina's is now 10, and Eva's is now 9. See? The ratios are still the same. Eva's to Carl's is 9 to 6, which is the same as 3 to 2. Carl's to Dina's is 6 to 10, which is the same as 3 to 5, but we all got a one nice ratio. Genius. Okay, so now all we need to do is what we did before, sharing out a ratio. It means if Eva gets 9 oranges, Carl gets 6 oranges, and Dina gets 10 oranges. So if we would give them those oranges, we will be handing them a total of 25 oranges. Okay? But we're not handing out 25 oranges, we're handing out 100 oranges. So we need to keep giving Eva 9, Carl 6, and Dina 10 until we've handed out 100 oranges. And to do that, we have to do it 4 times. So all we need to do now is multiply this ratio by 4. So 9 times 4 is 36. 6 times 4 is, what's that again, 24. 10 times 4 is 40. That should add up to 100, doesn't it? 36 plus 24 plus 40. 100 oranges, and the ratios are all intact. So Carl receives 24 oranges. There we go. Okay, yeah, so they kind of show the same equivalent ratio thing I've done. You add it together, and then I don't know what they did there, but anyway, got the right answer. Along comes Fred. Doesn't want oranges. He was buying a house. So this seems a bit complicated, but if you don't know what something is, what do we must make an X? So calculate how much Fred paid for his house. We don't know what it is. Let's say he paid X amount of dollars. So that means he paid X. At the end of the first year, the value of the house increased by 5%. So if you remember, if you increase something by 5%, you take 100%, which is the amount Fred paid for the house. You add 5%, and you end up with 105%. Which is a multiplier is, yes, divided by 100, 1.05. So if we take the amount Fred paid, which we made X, we multiply it by 1.05. That means at the end of 1 year, the value was 1.05x. Nice. Then at the end of the second year, the value of the house increases by 3%. So we do the same thing. We take 100%, which in this case will be 1.05x. We add 3%, we'll end up with 103%, which is 1.03 as a multiplier. So we take the value we have, which is 1.05x, We multiply by 1.03, and then we know how much. So we put 1.05 times 1.03, and that's how many x's is the house, 1.0815. So that is how much Fred paid for the house. Oh, no, that's how much the house was worth after 2 years. But we know what that was actually. The house at the end of the second year is 60,564. So that means that must be equal to 60,564. So to find out what x is, we just need to solve this equation. To do that, we divide both sides by 1.0815 or divide the 1.0, yeah, 815 on the other side. You know, change sides, change signs, times becomes divide. So on the calculator, we can just type in 60,564 divided by our previous answer, which was 1.0815, and we get this beautiful, beautiful exact answer, which feels like this must be correct. And so it is. Okay, again, it says not from wrong working. What about that? Is for the first step I did, and then we divided it. Okay, so looking at the mark scheme, 1 mark for multiplying that together there, 1 mark for dividing the answer, and then we got the right answer. If you get stuck with anything, just do what you can. So say same with question D. Okay, it seems complicated, but again, we're doing compound interest, so we go back, we just use the compound interest formula and we write it down. Okay, first sentence, compound interest, write it down. So compound interest is the amount equals P1 plus R over 100 T. Then we just put in there what we know. We know the principal P is 500. We got 1, we got plus. We don't know the rate R, so it stays in R. We got the time, 8 years. And we got the amount of the investment, 609.2. Remember, compound interest does give you the whole amount. Okay, and then we just need to solve this. So first I want to get rid of that 500, so we divide both sides by 500 or divide the 500 on the other side. And here we'll be left with 1 plus R over 100 to the power of 8. Okay, I'm going to leave it like that for now. The next thing we will want to do is we want to get rid of the power 8 because we can't use anything in the bracket before we do that. So we're going to get rid of the 8, we need to root 8 both sides or root 8 the other side. So moving that over there, we do root 8 609.2 over 5. And now the brackets is gone. We set free the 1 plus R over 100. I think here I'm going to do the calculation. Okay. So we're going to shift root. So I can put any root in there. I'm putting a root 8. And under the root, we got 609.2 over 500. And that looks quite familiar. It looks exactly like a multiplier. 1.024, what else? 9, etc. Okay. So now, all we need to do is get rid of the 1. We subtract the 1 on the other side. We'll be left with R over 100. So let's do that. So just subtract the 1. We got 0.0249. And then we just multiply it by 100. And we got the answer. Nice. Which should look like a very reasonable answer. 2.4999. Okay, of course we want to probably round this to 3 significant figures. So 1, 2, 3, cut it off there. There's a 9, so we need to round up this 9. What comes after 49? 50. So 2.50. Let's look at the mark scheme. There we go. 2.50 is optional. So you write 2.5 is fine. Or if you write the unrounded answer, like I did down here, still get full marks. Okay. So that's it. Nice. And easy. See, you start with what you know, and then things usually sort itself out. Right. Question 2a. 100 students take part in a reaction test. You know, it's like when they drop their ruler and you catch it, like, yeah, like something like that, or maybe, who knows. Write down the mode. Okay, so this is the most. What is the reaction time of most of the students? Right? Number of students. There were 32, that's the highest number of students, that had a reaction time of 7. So the reaction time that occurred the most was 7 seconds. See, we need to get the answer from the seconds row because there's an S there. But we use the 32 to find the answer because that's what most students got. Right, next one, median, remember, means middle. The middle. Okay, so what we need to do is we need to take all these 100 students and line them up. Okay? And then first we're going to have 3 students that had a reaction time of 6 seconds. So we'll have 3 6s. Then we need to put 32 students that had a reaction time of 7. So we have 32 7s. Now I'm not going to write 32 7, but you get the idea. There are 3 6s, 32 7s. Then we need to put the 8s. And of them there will be 19. Then we put the 9s. Not right, but there were 29 9s. Okay, then we'll write the 10s. Everybody that got 10, there will be 11 of them. And at the far end, we'll have 6 people that were the slowest. So we'll have 6 11s. Okay, so they're all lined up. Fastest reaction time, slowest reaction time. Okay, imagine that. Then we have to find the student that is in the middle. Okay, how do we find the middle of something? Well, we take the 100 and we just half it, right? But you have to add 1 before you half it, which gives you 101 divided by 2 is 50.5. Okay, why do you add that 1? Because if you just divide it by a half, so 100 divided by 2 is 50, and you got the bloke in the middle, the 50th person, you'll have 49 to the left, and you'll have 50 to the right. Does that make sense? That's not exactly the middle. It's like we've got 5 numbers. 1, 2, 3, 4, 5. Where's the middle? The 3. Yeah, but if you do 5 divided by 2, you get 2.5. Tells you the middle is between 2 and 3. But if you add 1, which is 6, you get 3. That's the middle one. Alright, so the middle is between the 50th person and the 51st person. So we split them in half. 50 people here, 50 there. The middle is between the 50th, 51st person. So where would that one be? Well, we got 3 people lined up. Then at the end of the 7s, 3 plus 32 is 35 people. And then there's another 19. So by the time we get to the end of the 8-second ones, what would that be? That would be 54. Okay, just like a cumulative frequency. 35 students up to here, 54 students up to here. So the 50th person and the 51st person will be one of these ones that took 8 seconds. So the median, and what's halfway between 8 and 8. So the 50th person took 8 seconds to react to whatever the test was. 51st person took 8 seconds. What's between 8 and 8? 8 seconds. There we go. 7 for the first one, 8 for 2a part 2. Right, then we calculate the mean. This is where we have to add up everything and divide it by how much there is. Okay, we already know the number of students. If we add up that row, that will equal to 100 because they told us. But check it, yeah? Are we going to add these seconds up? The 6 plus 7 plus 8 plus 9 plus 10, 11. No, it's not going to help just to add 6 plus 7 plus 8 plus 9 plus 10, 11 because they represent more than people. This 6 represents 3 6s. So what we need to do is we take the first 3 people and add up all their 6 seconds. So together they had a reaction time of 18 seconds. Yeah. Then we take these 32 people who had a reaction time of 7 seconds. What is that? 294 seconds altogether, the reaction times. Okay, we need to add up all the times of all the people. So the next one will be 19 people who had a reaction time of 8 seconds. Then we got 29 people, reaction time of 9 seconds. Is that plus the, it's a bit ugly. Then we got 11 people, reaction time 10 seconds. And then we got 6 people, reaction time 11 seconds. So let's work out, if we add all the reaction times together, what do we get? Okay, it's a bit of a calculation. Take your time, make sure you do it right. (831 seconds). That's everybody's reaction times together. Then we need to divide it by how many there is. How many people took part? 100. So the reaction time is 8.31. Okay, now always it's very easy because this is a big calculation. It's very easy to make a calculation mistake. So it's important to show all you're working out, and then you think, does it make sense? 8.31 seconds. Yeah, it's somewhere in the middle and it's close to the median, so it could be correct. So it looks good. I mean, if you got 6 seconds or 11 seconds, you're probably wrong, but you won't know. Just think, does it make sense? Well, mark scheme says 8.31. Okay, you see how important it is to show the working out because it counts marks. If you make a mistake, you can still get 2 out of the 3 marks. Show your working out. Part 4. 2 students are chosen at random. Find the probability that both the reaction times are greater than or equal to 9 seconds. Okay. So, we're now looking at these students. We have to pick one of them because their reaction times is 9 seconds or greater. 9 seconds. So how many of them are there? Well, that's 29 plus 11 plus 6. Let's do that first. 29 plus 11 plus 6. What is that? That's 46 students that we can possibly pick. Okay. How do we write a probability? As a fraction. So 46 out of 100 is got a reaction time of 9 or more. So when we pick that first student, okay, remember we have to, probability of picking him is 46 out of 100. Okay, but then we're gonna pick another one. Are we gonna pick the same student twice? No, we're not. We're gonna pick the ones that stand over there and we pick another one. Okay, so that means the second time we pick, there will be one less student. Alright, and we have to pick a student again from that group, but we picked the first one from that group, so there will be one less student that has the time as well. Okay. The probability of picking the first one is 46 out of 100, but then picking another one will be 45 out of 99 because there's one less student. Then we think, what are we going to do? We're going to add this or multiply this, alright? So remember the rules. If it's or, we add. If it's and, we multiply. And here we have to pick one student and then pick another student. It's not we pick the one or the other one. No, we have to pick two students. That's got a greater time than 9 more seconds. So we're going to multiply those two together. So let's do that. What do we write? Write it as a fraction. It doesn't matter. 23 out of 110. Let's see. 23 out of 110 or equivalent. So it just means if we did write it as a decimal. Any of that? This is also correct. Okay. And how many marks is this? 2 marks. So you get 1 mark for writing down the probabilities and then getting the answer. Nice. Part B, a box and whisker plot. Show the heights of some students and they make them do reaction tests, then they measure how tall they are. Find the range. Be careful, this is not the interquartile range, it's just the range. Okay, so we take the highest value, which is this one over here. Be careful with the scale. It seems like there's 10 squares between 150 and 160, so each square counts for 1. So the highest score there would be 158. And then the lowest, or the lowest height, yeah, that seems to be right in the middle, yeah? So that's 105. And what would that be? 53 centimeters. So the difference between the tallest and the shortest, 53 centimeters. Now it's the interquartile range. Now we take the upper quartile. Remember now, right? This is the upper quartile. This is the lower quartile. And this is the median. So the upper quartile, 142. Lower quartile, 122. And what's that, 20? Okay, we're on track. Finished? Put box and whisker plots. Oh, that was fun. I like it. I want more. Right. Now we're up to potatoes. We've done with the students. Then I have to feed them. The table shows the results of the mass of 200 potatoes. So they didn't give the exact mass of every potato. They just told us there is 60 potatoes that measures between 50 and 110 grams. There's 99 potatoes between 100 and 200, and the big potatoes, 41 of them, are 200, 300. Okay. Calculate an estimate of the mean. Remember now, we've done this before. We calculated the mean here, and then from this table. So again, we need to basically take all the potatoes, throw them in a big bucket, put it on a scale and see how much does all the potatoes weigh all together. Okay. Now it's just, we don't know exactly how much of the potato weighs. We only know that they weigh in a range of weights. You don't have their exact weight. This is why we can only do an estimate. We can't do an exact mean calculation. So what do we do with these 60 potatoes? The weighs somewhere between 50 and 110. We're going to take an average, and the average is the midpoint, right? To find the midpoint of two numbers is not that hard. We just need to add them together. So we do 50 plus 110 and divided by 2. So 160 divided by 2 is 80. So half point, there's 80. So we're going to assume that on average, these 60 potatoes weighs 80 grams. Okay? So those 60 potatoes on average weighs 80 grams, which in total would be, what is that? 4,804.8 kilograms. But that doesn't matter. Okay, then we need to add all the potatoes, the 99 potatoes that weighs between 110 and 200. Again, the midpoint will be 110 plus 200 divided by 2. What's that? 310. What's halfway? 155. Yeah, 155. Just also always good to double check. Save your brain power. Okay. So 155 is the average weight of those 99 potatoes. So we're going to do 99 potatoes on average weighs 155 grams. The last one, oh, this one's easy, isn't it? It's 250, halfway between 200 and 300. So 41 potatoes on average weighs 250. Okay, let's work that out first. So 30,395 grams. More than 30 kilograms of potatoes. That's how much we estimate all those potatoes weigh. We don't know exactly. So, what is the mean weight of one potato? Well, we need to take that 30,395 and divide. How many potatoes do we have? We can add up these 60, 99, 41, but that will just give us 200. They're already given it to us. Okay. $151. That decimal point shouldn't be there. 0.975. Okay. Now, do we round this? Well, the thing is, this answer is actually exact because it's not a continuous number of decimals, all right? So we can consider this as exact. Let's check. Yeah, see, so don't round this. This is an exact number. You only round it to the three significant figures if it's not exact. So if it was 975,423, non-recurring, non-terminating decimal values, then you round it. Don't round this. Okay. Always think, does it make sense? 151 grams is there somewhere in the middle. It makes sense. Okay. Lots of marks here. Alright, so you get a mark for the midpoints, using the midpoints, right? So write it down, even though it says seen or implied. So if they can figure out you've used midpoints, they'll give you that mark. Then for adding up everything, you get a mark. Then for dividing by 200, you get a mark, and then the final answer. So we're up to part 2, which is about histograms. The one thing I always just remember with histograms, and this helps me figure out everything, yeah, is that the area of this rectangle, of the bar, equals the frequency. So you see, this goes from 50 to, that's supposed to be 110, yeah? Like in the bar, that's 50 to 110. So that is, the width of this bar is 60. And that goes up to 1. Okay, so this is 1, this is 60. 1 times 60 is 60. That is the frequency. Bam. Okay, which makes sense. The width of the bar. So the formula is a class width. This is the class width, how wide it is, times the frequency density equals the frequency. If you want to draw a triangle for this, it's always the frequency, how many there is, equals the class width times the frequency density. That's a way to help you remember the formula. Okay, now what we need to complete this, we need the frequency density to know how high the bar is. Okay, so we want to rearrange this, we need this, so we need to do the frequency divided by the class width. That will give us the frequency density. So the first one here, the frequency, the 99 potatoes, is the frequency, 99 potatoes we divide it by the class width. From 110 to 200, how wide would this bar be? 90. Okay, and that will give us 1.1. Does it make sense? Yeah, 1.1 will fit nicely here. Okay, let's just work out the other one then as well. So the frequency for the last bar, 41. The class width is 100. Easy. So 41 divided by 100 is 0.41. So let's draw those bars. Use a ruler and a pencil. Okay, so what are we doing? From 110 to 200. So a bar is going to end there. We need to go up to 1.1. So how many squares? Every 2 squares is 0.1, 1.1, 1.2, 1.3. Yes, good. So let's go. Man, I hate this because it's difficult on a screen. I need to get a better program. Why is it doing that? .41. This one's harder. Okay, this is the 0.1, 0.2, 0.3, 0.4. So we'll be just above that. Right, don't color it in. At least you have time at the end. Yeah. Yeah, we got the bars in the right places. That's it. Question 3, they got a ball in a tube. Right. Just take this slow. The diagram shows a cylinder containing water. There is a solid metal sphere touching the base of the cylinder. Very important, it touches the base. I think that's important. Half of the sphere is in the water. Good. Because, yeah. The radius of the cylinder is 12. Got it up there. And the radius of the sphere is 3. So if it touches, you see, the sphere radius is always the same. Sideways, down. Okay. The sphere is removed from the cylinder and the level of the water decreases by h. Show that h equals 0.125. I'm also baffled. So what I would do, I just start with what there is. And I give us a formula. And we use that formula. So this is the volume of the sphere. I want to use green. The volume of the sphere is 4/3 pi r cubed. Okay. But now remember, if we're going to take out the sphere, it's only half the sphere being removed. So we just need that half that's in the water. Yeah. Because that's what fills that space. We take it out, the water level drops, but by the volume of half that sphere. So we're going to have to divide this by 2. Because we only need the half that's in the water. Right, so the volume of that hemisphere is 4/3 pi, the radius of the sphere being 3. Yeah, so that's 3 cubed divided by 2. So let's work that out. Okay. Right, so we can use 56.548. Yeah, just don't round this. Because if you round this to 3 significant figures, your answer is not going to be accurate enough, and then you're not going to get full marks. Okay, it says that in the examiner's report every single time. So at least use like 5 significant figures, or even better, 18 pi, because that is the most accurate way to write this answer. 18 pi. Okay, you can just change 18 pi to a number later. Okay, so use lots of figures or use 18 pi. So that's the volume of the hemisphere, okay? Now, when we remove it, the water level drops. Okay, so we need to imagine that volume of the hemisphere as a cylinder. So imagine we just squeeze that hemisphere flat into a little flat cylinder and then take it away. That would be how much it drops. So what we really want to do, what is the volume of a cylinder? Do you remember that? The volume of a cylinder. Okay, the volume of a cylinder is like any prism. It's the cross section of a cylinder, yeah, which is just the area of a circle times the height. Study this, yeah? This one you need to remember. Volume of a cylinder, pi r square, area of a circle times the height. It's not that difficult. And that is what we're taking off. The volume being removed. Make sense? So it means that height is the one we want, and the volume is what we remove, which we worked out, which was 56.548 or 18 pi. The radius of the cylinder would be a flat cylinder with the radius of this cylinder, that will be 12. And this is what we want to work out, the height of that little cylinder. So, if we want to work out the height, all of this is being multiplied with the height. So if I just divide both sides, divide it on the other side, we should get a good answer. So, I mean, you can do 12 squared is 144, is 144 pi. Anyway, this is what we're going to do. We're going to do 18 pi divided by pi times 12 squared, which is 144. Bam. So the height is 0.125. You need a bit of an imagination here to figure out. So I can go through what they do in here, but it's basically the same. I just did it in a more complicated fashion. Yeah, half, they divide it by 2. They make it a bit complicated or equivalent. There is another method, which will take all day. Okay, this is the shortest method. How do we do it? Okay. The water in the cylinder. Remember, the water in the cylinder is still the same. The level just dropped when we took the ball out, but the amount of water doesn't change. It's put into another cylinder with a radius r. The depth of the water in the cylinder is 18 centimeters. Calculate the value of r. The radius, can we just measure it? But anyway, right. So just imagine now we've got a different cylinder. Yeah. Then in that cylinder now we put the water in, and now it's bobbing up there. And what we know here is, we don't know what is the radius, but we know the depth there is 18 centimeters. Okay. But I think first we should calculate the volume of the water, because we've never done that. We don't know what is the volume of the water. We know what was the volume, yeah. So remember now, when we took the sphere out, the water level dropped a little bit, like that. Okay. And the height, of course, dropped by 0.125. So we got a new height. What is 3 minus 0.125? I think it is 2.875. Check. 3 minus 0.125. Yeah. So first we would have to calculate that volume of water. Okay, so let's call this cylinder A. Okay, so volume of the water, not the whole cylinder, and that's a cylinder by the way, volume of cylinder A. Remember we're using pi r squared height to get volume. So that's pi, the radius of this cylinder is still 12. And the height after we took out the sphere was 2.875. Okay, let's just work that out. So we're doing pi 12 squared times 2.875. Right, we can use 1300.619, yeah. Don't round it, use lots of figures, but better, more accurate, if you can, 414 pi. By the way, if your calculator doesn't give you the answer in pi, you can just do this calculation without the pi, yeah? Just 12 squared, yeah, you see, what you do is you just do everything without the pi, and you just add the pi at the end. Alright. Now we know what the volume of the water is that we poured over into this one. Let's call this cylinder B. Okay, so the volume of cylinder B again is pi r square h. What do we have? Well, we got the volume now. I'm going to use this, more accurate, is 414 pi. So pi, the radius, we don't know. They make it big R squared. The height they told us, 18 centimeters. Okay, let's move stuff, get rid of stuff. So first, the pi, move it to the other side, divide both sides by pi. That's neat because that would just cancel the pi's. So we're left with 414 equals r squared times 18. Then divides both sides by 18. I'll divide the 18 on the other side, which I will do in a minute. But before I do that, get rid of the square, square root both sides, square root the other side, you know, move that over there. So we can do all at once. So what I want to do is square root 414 divided by 18. And now we got the answer. R equals 4.7958, etc. And now we've got the most accurate answer. We can round it to 3 significant figures. So 1, 2, 3, cut it off there. That's a 5, so we need to round it up. 79 becomes 84.8. Yeah, 3 significant figures. There we go. The 0 is optional, so 4.8 is 5. Or if you write the unrounded answer there, they also get full marks. Nice, we've done it. Nicely done. Question C. Now we're going back to the sphere. It's melted down, and some of the method is used to make 30 cubes. Oh my goodness. Right, let's go at the slope. So you take the sphere. Alright, nice. I can imagine making very hot, melting down. Yeah, so you got this liquid metal that you can pour. Yeah, very nice. But we need the volume of that sphere. And we can use this formula, but we did kind of work it out last time, didn't we? We worked it out here in question 1. Yeah, we worked it out there, see? Only thing is, we divided it by 2. because we worked out half the sphere. Now we just need to double it and we have the whole volume. So we can take this answer here and double it, or even easier, the 18 pi, okay, which is easier to handle. So I'm just going to write the volume of the sphere, we know that's a sphere because you don't have a volume of a circle, is, the hemisphere was 18 pi, we double it, so we got the whole thing is 36 pi. The whole sphere, volume is 36 pi, or 56 point whatever times 2, 56.548 times 2, okay, nice. Right, so then we got little cubes, yeah, so imagine a little cube, edge length is 1.5, and the nice thing about a cube means all the sizes is the same, so to get the volume of the cube we need to do 1.5 times 1.5 times 1.5, or simply 1.5. I really am bad at making fives. 1.5 cube. So that one cube will have a volume of 1.5 cube. And we got 30 of those cubes, so we need to multiply that by 30. Let's do that. Okay. So we're going to do 1.5 cube, 1 cube times 30. That's 101.25. We're working centimeters cubed. Okay, so we took that liquid sphere that's melted and we poured it 30 times, and then we got some liquid left. So let's see, what's liquid left? So we have to take the volume, okay, this was also centimeters cubed. So the 36 pi, we subtract all the liquid we poured out, we'll have the volume of the liquid metal that is left. So we just need to do 36 pi minus my previous answer, which was 101.25, and that's what's left, 11.847. At least 5 significant figures, don't round it yet. We're making progress. Just calculate the percentage of the metal that is not used. So we know the amount of metal that is not used is 11.847. That's the metal being not used. How do we calculate a percentage? Just like when you've got an exam, you write your mark, or in this case the metal we didn't use, which is 11.847, divided by the total amount of the metal, total amount of the volume of the sphere, which we had as 36 pi. Oh my goodness. Try that again. 36 pi times 100 because it's percentage. So let's do that. I still have the previous answer. This all I need to do now is divided by 36 pi. There's the decimal answer times 100. 10.475. Etc. Now we can round it. 3 significant figures. So we cut it off there. There's a 7. So we round the 4 up to a 5. So 10.5%. 10.5 is correct. If you write the unrounded answer, you also get your marks. Sweet. We've done it. Right, jumping onto the desktop here for question 4. Right. First one, enlarge triangle T by scale factor 3, center 0, 2. So 0 along the corridor 0, 2. That would be there, isn't it? Yeah? X is 0, Y is 2. Along the corridor, up the stairs. Always make sure. Okay, so we already know we need to make this shape 3 times bigger, but also the distance from the center needs to be 3 times more. So it's going to draw a little guideline here. Okay, so the distance here from the center to this top corner is 3 squares. So we need to triple that from here. So instead of 3, we need to go from here 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. So that point's going to be there now. Okay, let's do the bottom corner here. Okay, let's draw a guideline there. So this distance diagonally from there to there is 1 squared triplet. So we do from the center 1, 2, 3. It's going to be over there. Okay, last one. Alright, do we need to count it? Because we know it should be over there, yeah? Just check if the sides are correct. Triangle is 1 square high, now will be 3 squares high. The base of the triangle is 2 squares, now will be 1, 2, 3, 4, 5, 6. Yep, that makes sense. There we go. We have enlarged it by 3. Going to part 2, rotate triangle T about 4, 2. So let's check carefully. Along the corridor to 4, up the stairs to 2. So that will be the center of rotation right there. Okay. 90 degrees clockwise. So get some tracing paper out. Roughly trace the shape. We'll go in clockwise. Look at the clock. Goes this way around. Okay, and make a corner of a turn. There we go. So that's where the new shape would be. Okay, let's draw it. Alright, if you're not sure if it's been correct, look at this. This angle here, there, that is 90 degrees. So that's correct. Okay, very important. Just label the image P. So do that. You never know. You might lose marks. Yeah. So make it very clear. Show that you're smart. That is P. Part B, reflect triangle T in the line x plus y is 6. What does x plus y is 6 look like? Alright, just guess some values, right? So they're saying x plus y is 6. So pick a value for x. So if x is 1, y must be 5, because it needs to equal 6. So x is 1, see, so that will be a point on the line. If x is 3, then y must be 3, because it has to equal to 6. So 3, 3 will be a point on the line. If x is 0, then y must be 6, because it has to x. So x is 0, so it's going to be that point there. If x is 6, then y must be 0. So it needs to go for 6. So the line x plus y equals 6 goes through the points 6, 6. So that would be the mirror line. Okay. We're refracting triangle T in this line. Alright, so when we reflect, each point needs to be the same distance from the reflection line on the other side. Okay, and we're going diagonally at a right angle to the reflection line. Okay, so if this T is half a square away from the line of reflection, it needs to be half a line. That's going to be a point on the reflected shape. This is 1 square diagonally. We go 1 square on the other side. And here going diagonally, 1, 2, we go 1, 2. That's what our triangle is going to be like. Okay, it's going to look like this. My goodness. Okay. I mean, you can also reflect the shape and then kind of fold it over in that line. It's going to work. Alright, in that line, it should be on the shape there. Yeah? Okay, and then label that Q. Question C. Describe fully the single transformation that maps triangle P onto Q. So how do we get from there to there? Okay, 2 marks. Remember, there are 4 types of transformations. There's enlargement, there's rotation, there's reflection, and then there's translation. Alright. Can this be an enlargement? No, it doesn't change size. Can it be a translation? Well, a translation, it just moves across like this, so nope. Can it be rotation? Nope, it flips over, just like we flipped that one from there. So it can only be a reflection. So you need to write that down. That will give you 1 mark. Okay. What else do we need for a reflection? We need the mirror line. Okay. So we write the mirror line is this line here. You see that? It's a line that goes through 4 on the x-axis. So you write x equals 4. And you've done it. Right, we are back on the touchscreen and we are doing question 4b, vectors. These questions are just lovely. They are so nice. Right, let's go very slow through every piece of information. The diagram shows OHK, where O is the origin. O is where everything starts, everything moves, wherever. You imagine your O is a city and you're driving on some roads away from O. The position vector of H is A. Okay, so that's just mean from O to H is A, and the position vector of K is B. It just tells you you're going to have to use these A's and B's, yeah? Z is the point on HK such that AZ to ZK is the ratio of 2 to 5. Okay, I'm going to zoom in a little bit, okay? So the ratio here is 2 to 5. So that is 2 from A to Z, Z to K is 5. Okay, that means that actually they have divided this line into how many parts? 1, 2, 3, 4. See? How many parts is that in total? 1, 2, 3, 4, 5, 6, 7. They've divided that line into 7 parts, and HZ is 2 of those 7 parts, and ZK is 5 of those 7 parts. So you can say HZ is 2/7 of the line, and ZK is 5/7. That's the ratio 2 to 5. That was very helpful, isn't it? Okay. Find the position vector of Z in terms of A and B. So position vector means we want to, the position vector always starts at the origin and it goes to, so we want to know what is this vector here. Okay, in that direction. Now the thing with vectors is you always need to follow the path that you know. Okay, so if we want to find the vector of HK, which we do need to find, don't have it, in terms of A and B, we're going to have to follow a route that we know. Okay, so I want to know now what is HK. So I'm going to write HK is a vector in that direction. I'm going to have to follow this path here. I'm going to have to go the route I know, which is HO in that direction. You've got opposing arrows, which we'll deal with in a moment. And then go along this route here, which is OK. OK, nice, I like that. Right, so what do we know about these things? Well, we know HO goes in the opposite direction of A, so it's minus A. And OK, we're going with the B, so that's a positive B. Okay, and to make things look nice, we can always just swap them around. So it's B minus A. Minus A plus B, same as B minus A. So we know now that HK is B minus A. Okay. Which makes, squeeze that in there, HZ 2/7 B minus A, and ZK 5/7 B minus A. Right, progress. Now we want to find the position vector Z. That's the green line. Let's swap to green, okay? So what we actually want to find is OZ. That is the position vector OZ. Okay. To find that, we are going to use a path that we know. Okay. Let's use a light green. So I'm going to use this path. I'm going to go along OH in that direction. And then add this path here, which is HZ. What do we know about these two paths? Well, we know OH is A, that's easy. And we know HZ is 2/7 B minus A. And that's it, we got the answer, we've done it. Okay? Just be careful, it says give your answer in its simplest form, and that is not the simplest form. But we can do it, we can deal with this. Alright, so that means OZ is A, just expand the brackets. So 2/7 times B is 2/7 B, and 2/7 times minus A is minus 2/7 A. Alright, so all we need to do now is collect like terms. So we got A, imagine there's like 1A minus 2/7. What's 1 minus 2/7? Of course, that is having like 7/7, which is 1 minus 2/7, that is 5/7. So we got 5/7 A mosquito plus 2/7 B. We've done it. The answer is 5/7 A plus 2/7 B. There we go, 5/7 A plus the final answer. Okay. Look here, you get a mark for indicating a correct root. Okay, this is why I write these steps here. Because even if you mess up everything, you don't have a clue, but you write the root correct, like this sentence here, you can get a mark for that. Okay, so and that's an easy mark to get. I mean, if you struggle to get full marks here, you can easily pick up a mark with just writing down the correct root. So have a go at that, yeah? Have a go. Good tip. Use it. Question 5a, expand brackets and then simplify. Let's do that slowly. So first we're going to do using FOIL, yeah? First and first. So numbers, 2 times 3, 6, p squared times p squared is p to the power of 4. Next, first and last. So 2 times minus 2 is minus 4. P squared, there's nothing else, stays p squared. Then last and first. So minus 3 times 3 is minus 9. And again there's a p squared, stays the same. And then we do the last with the last. A negative and a negative becomes a positive. I bet if you look in the examiner's report, then they're going to say people got that wrong. See? Yeah, there it is, you see? A wide variety of mistakes included giving a minus 6 instead of plus 6. Everybody makes that mistakes. 2 negatives makes a positive. 3 times 2 is 6, right? That's a plus there. Right, then we just collect, we simplify. We've done the expanding, now we simplify. 6p to the power of 4, there's no other term that matches that one. The only terms that matches up is these middle two. The p squares. So we can do minus 4, minus 9 is minus 13. P squared. Okay, remember now, we're not multiplying, so 2 negatives doesn't make a positive. We're simply subtracting. We're at minus 4, we minus another 9. And then we got the constant term, as they called it. 6p to the power of 4 minus 13p squared plus 6. There it is. Okay, 1 mark for the answer. So the expanding gives you 1 mark, simplifying gives you the 2nd mark. Right, next one is simple substitution. So we got a half, u is 20, v is 30, t is 7. Alright, put this 7 in brackets. You can't just put a number at the end of the brackets. It's multiply, it needs to be in brackets. Okay, what's it? 50, 350 divided by 2. Wait, Cheetah, you're not going out now. I'm busy. Okay, so use the calculator anyway. So a half, 20 plus 30, 775. Isn't that what I said? That's what I said, Cheetah. Okay. Just hang on a second. I'm gonna let this dog out. So where were we? Rearrange the formula to make v the subject. That's what they're saying. Write v in terms. So we have to move the v by itself. Okay. So this is what we call peeling the onion. So that v needs to stay where it is. Everything else needs to go to the other side. Okay. So start as far away from the v as possible. It's peeling the onion. So what's this? This is a half. We need to move the half to the other side, or we need to get rid of this with multiply both sides by 2. Whatever way, yeah, you need to multiply by 2. So that will give us 2s equals u plus v times t. Next, get rid of the t, so divide both sides by t, or divide the t on the other side, so that gives you 2s divided by t. And now the t was like a guard in front of the brackets. Now that it's gone, the u plus v is free. We can now leave the brackets. Okay. Last thing is move that u. The u is a positive u, or to get rid of the u, you need to subtract u from both sides. Oh, we've done it. Done. Final answer, 2s over t minus u. I suspect there's probably another answer. If you got common denominator, something like that. It's probably more than one answer. Let's see what the mark scheme says. Yes, see, that's also a possible answer. This is the one I wrote. I think mine is a bit easier. Okay. If you really want me to explain the other way, leave me a question in the comment section. Factorize. Let's just do the first part first. Okay. Common factor of 2qt minus 3t is t. So taking that t, put in front of the bracket, left is 2q minus 3. Okay. No, there's no bracket. Okay, then let's leave that there. What is the common factor of 6 and 4? 2, right? Common factor of 6 and 2 is 4. 2. 6 and 4 is 2. So we're going to take a 2 out of that bracket. Okay. So what's left? There's a 3 plus 2q. Be careful here. Be very careful, right? Be very careful, because that is not correct. Because minus 2 times 3 is minus 6. And minus 2 times plus 2 is minus 4q. That's not what we have there. So if I want to do this right, I need to put a minus there. Now it's correct, okay? Because if I expand it again, minus 2 times minus 2 gives me plus 4q, and that's what we need to have. But I suspect there's something else going on here, because can you see these brackets are very similar? Okay, so what I think they want us to do is factorize out the negative. Like, for example, if we make this positive and this negative and this positive, then if we expand those brackets, we'll have 2 times minus 3 is minus 6, and 2 times 2q is 4q. See, this is the same as before. So if we make this positive and that negative and that positive, it's all still true, it's all still correct. But now, look at this. I'm going to leave the first bracket the same. Just going to swap the 2q and the minus 3. We can do that. We can swap them around as long as the minus stays with the 3. Yeah? Because now we can factorize out this whole bracket. Okay. We take that whole bracket and we factorize it out, which means we put it in front of the bracket. It's kind of like if we had tx plus 2x. We can factorize out that x and we're left with t plus 2. Yeah? Okay? But now we don't have an x, we've got a whole 2q minus 3. So what's left is t plus 2. Fun and games this is, yeah? There it is, final answer. And there's another way of doing it. They rearranged it kind of and did it a different way actually. Maybe their way was easier than mine. Anyway, I got the right answer. Part 2. Common factor here is an x. We can take one x from there and that one x there. So we take one of those x's there, we're left with x squared, because x times x squared is x cubed. And we take the 1 from the 25, so common factor x. Nice. 3 marks, so this cannot be it. Cannot be it, right? Recognize that this is a complete square. Yeah? That's a square number, x squared. 25 is a square number, and there's a minus in the middle. So we can square root this. X times x is x squared. We put a minus 5 and a plus 5, because minus 5 times plus 5 is minus 25. And that is fully factorized. X minus 5, x plus 5. Just quickly, if you're not sure why that works, well, if we take this x minus 5, x plus 5, and we expand it again, we get x times x is x squared. X times 5 is 5x. Minus 5 times x is minus 5x. And minus 5 times plus 5 is minus 25. Then the two middle terms, 5x minus 5x, will cancel and we're left with that. This only works if we have everything squared and a minus in the middle. So for example, if you've got a squared minus 36, yeah? That will be a minus 6, a plus 6. So as another example. Alright, hope you understand. Have we checked the answer? Yep, that's correct. I've got the minus first and then the plus. They got the plus first and then the minus. That doesn't matter at all. 1 mark for that. Oh my goodness, what are they doing there? Don't even look at that. Okay, 1 mark for the basic factorization, 2 marks for the whole, because it says factorize completely. Question 6. So here we go. We've got some straight lines there. We've got the x and the y axis. You see that? Yeah. Just to make things clear. Sometimes it can become. This is not working. Yeah. That's the y axis. That's the x axis. Then we got some lines. All right. Write down the equation of L1, line 1. Yeah, I guess L stands for line. Line 1 is a line parallel to the x-axis, okay, that goes through the y-axis at 4. So wherever you are on that line, y will always be 4. Will you ever cross the x-axis? No. That's why there's no x in the equation. It's easy as that. It's a line that goes through 4 on the y-axis is y equals 4. Sweet. Then find the equation of L2. Give your answer in the form y equals mx plus c. Okay, so remember this. The c is the y-intercept. It means that is where the line crosses the y-axis. It crosses the y-axis again at 4. So at the end of our equation, we'll have a positive 4. Okay, easy stuff. Then, of course, we have the x as well. The x will stay there. We just now need to find out what is the m. The m is the gradient. Now remember, m gradient is always the change in y over the change in x. I know my handwriting is ugly, I do apologize. This doesn't count marks though. All I like to say is the up and down over the left and right. Okay, so looking at that, the up and down, if we draw a triangle, up and down is 4 and the left and right is 8. Nice. Okay, one thing though is to be careful here. Okay, so we could say the gradient is the up and down is 4 over 8. If I'm moving from this point, from A to B, I'm going down, so the up and down will be minus 4. Okay. Or, if you don't like that, if you want to move from B to A, then I'm going opposite, then the left and right is minus 8. Doesn't matter we put that minus, you just recognize that this line is negative, it's sloping down. Okay, so when you're going to simplify this, 4/8 is the same as a half. You need to put a minus in front, or you put the minus at the top or the bottom, doesn't matter. Yeah, remember, minus a half is the same as minus 1 over 2, it's the same as 1 over minus 2. It's all the same, we tend to use this one. So saying my answer in the end, the gradient is minus a half, or minus 0.5 for that matter. Okay, so there it is, final answer. Okay, you get 1 mark for the minus 4 over 8, seen or implied, and 1 mark for the plus 4. That's what basically says there. Question C. C is the point 2, 3. Let's draw that for ourselves. Oh, goodness, that's not what I wanted to do. Okay, so let's jump to a different color here. So imagine the point 2, 3, 2, 3, 2, 3, like 2, 3. You see, this is not to scale, yeah? It's not to scale at all, right? So I'm just going to guess it's a point, let's say there, that's the point 2, 3, which is not to scale. Be aware. The line L3 passes through C and is perpendicular. Remember, perpendicular means it forms a right angle to line 2. Let's draw line 3 like we could imagine it being. Find my ruler. Okay, this is all just rough, yeah? So imagine there's a line, this is a 90-degree angle. Okay, this is not exact, it's not to scale. Okay, right, perpendicular line. Show that the equation of line 3 is y over 2x minus 1. Okay, so the first, again, we need to use the equation of the line, which is y equals mx plus c. So first, the gradient. Okay, we know the gradient of line 1 is not equal to, is, so that's the gradient of line 1 equals minus a half. So the gradient of line 3, now if they are parallel, it's the same. If they are perpendicular, what's it going to be? We need to invert and change the sign. Okay, invert means we swap that around. So it becomes 2 over 1, and a negative becomes a positive. 2 over 1 is the same as 2. Did you get that? Let me explain it a little bit better. Right, so here I got the line in red of the line y equals 2x, okay? And you can see the gradient is 2. Because for every 1 square that you go to the right, you go 2 squares up. Makes sense, doesn't it? Okay, so that's the gradient of 2. 1 square to the right, 2 squares up. Now if I draw a perpendicular line to that, that's the blue one. Okay, not only does the gradient change, so it's a line that has a positive gradient now becomes negative. Alright. Also, the gradient swaps around. Now for every 2 squares I go to the left, I go 1 square up. So from 1 to the side, 2 up, becomes now 2 on the x-axis, 1 up. That's it. That's why we invert and change the sign. So if I were to change this one, let's say to minus 2x, then if I want a perpendicular line to that, I'm going to have to change the sign to a positive, for example. If this is changed to a 3, so the gradient is steeper, I'm going to have to change this to a third to get a perpendicular. Easy as that. Okay, so that's how we now know that the equation of the line 3 has got a gradient of 2. Okay, so we can already write, so line 3 is going to have y equals 2x. What we need to find now is the y-intercept, okay? So on my badly drawn, not to scale graph here is where does this line cross the y-axis? We can't guess, we can't work it's not to scale. What we can do is we can recognize that we got a point, the point 2, 3. This is an x value, that's a y value, yeah? So 2, 3, the point they gave us an x and they gave us a y. So I can rewrite our equation now. We know that my equation is going to be y equals 2x plus c. We want to work out what is that c, but we've got an x and a y. So give it as, we know that y is 3, so I can change this y here for a 3. Now we know the x is 2, we change that for a 2. So 2 times 2 is 4. Subtract 4 from both sides. We get c is minus 1. Meaning that line there, that point there, that will be minus 1. It's not to scale, it doesn't make sense, but that is the truth of it. Now we've done it. Okay, so where did I give the marks here? Basically, yeah, you need to show how the gradient changes. I guess I will get my marks there for change that. Substituting, that's what I've done here, leading to that full marks. Okay. Right, part 2. Line 3 crosses the x-axis at D. Now we get a different color again. Let's go for orange. Right, so it crosses the axis at D. We need to find the length of CD. Now what was C again? C was the point 2, 3. So this is the point C. We need to find the length of this line. Sweet. Okay. If we have 2 points, the 2 coordinates, then we can do this. Because remember the formula for the length of a line. Do you remember it? It is simply Pythagoras, is it not? Where shall we write this down? The length of a line segment is the square root of x2 minus x1 squared plus y2 minus y1 squared. It's Pythagoras. Why? Because if you got a line segment and you've got a x value here, let's call it x2 and y2, and another point here, let's call it x1 and y1. If I subtract x2 from x1, I get the length there, and I would subtract y2 from y, get y there, and then I use Pythagoras to get the hypotenuse. The hypotenuse squared being x squared plus y squared, or the square root of x squared plus y squared. You need to remember that formula to help you. Now, we already have 1 point. We've got the point C, which is 2, 3 or 3, 2? 2, 3. Point D, we know, is on the x-axis. On the x-axis there. So we know that point will have a y value of 0. How do we find the x value? Well, it's easy. We got the equation. We got the equation of that line, which is y equals 2x minus 1. So we want to know what is the x value. We simply need, on the x-axis, we know the y is 0 because it's on the x-axis. We can put a 0 in there and then we can calculate. Move the 1 across, it becomes positive. Divide the 2, it's a half. X value is a half. Okay, so like over here, yeah, let's try this again. Let's say this is C and this is D. We know C is 2, 3. We know D is a half, 0. So if we use our formula, the length of CD is square root. So what are we going to do? Let's make this, I know this is weird. I'm going to make this x2 and y2 and x1 and y1. You can do it the other way around. It doesn't matter. Okay. So now if we do 2, because we're using x2 minus x1. So 2 minus a half squared. If you do it the other way around, you'll get a negative number, which doesn't matter because if you square a negative number, you get the same thing. Meaning 1.5, if you excuse me for swapping now to decimals, 1.5 squared is the same as minus 1.5 squared. Okay? And then we do y2, which is 3. So by the way, we now know that this length of this line is 1.5. Because 2 minus, yep. Okay, y2 is 3 minus 0, which is 3 squared. We now know the length of this line is 3, or up here. Maybe smaller, draw triangle there. That will be 1.5, that will be 3. Okay, good progress. Now we just need to work it out. Let's go for it. So what we're doing is 1.5 squared plus 3 squared. If you've done it the other way around, you have two negative numbers, put them in brackets. Okay, meaning if you got negative numbers, put the square outside the bracket. You get the same answer. This is just if you've done it the other way around. Okay. And we get the answer, 3.354. Yeah? Makes sense? If they're positive, we should get the same answer. Same answer. Rounded to 3 significant figures, 3.35. There we go. Rounded or unrounded, same thing. Okay, there you see. It says there half. This means if you got previous questions wrong. Okay, finding that half there. You've done it. Well done. Question 7. Venn diagrams, my favorite. Yeah, I think it's my favorite. Just ahead of vectors. Vector second place. Right. It says complete the Venn diagram. So let's look carefully at all the information. Right. E is the universal set. It's all the students in the class. It says the number of the universal sets, all the students is 24. So in total, in that block, everything needs to add up to 24. There's 24 students. Okay. P is the students who study physics. So look, everybody who studies physics needs to go in this oval of P. But there's already a 9. Alright? Inside that piece oval. So that means over here needs to be an 8, so that everything inside adds up to 17. Same for all the students that study chemistry. There must be 14 students who study chemistry. But in this oval of C, there is already a 9, so that there must go a 5 over here, so it adds up to 14. Then the intersection of P and C is 9. It simply means there's 9 students that studies both physics and chemistry. So everything makes sense. In P, there is 17. In C, there is 14. And overlapping is 9. Now if we add the 8, the 9, and the 5, what do we get? We get 22. But we know they need to be 24. So that means there's 2 students that is not studying physics or chemistry, but they're in the class. Question B is a really good question because it's surely going to show us now the difference between intersection and union. And I don't often do it like this, but this is the perfect question. Okay, so first, let's use red. No, let's use, what is that? Purple? Okay. We're saying find the number of people, that's P, intersect with the complement of C. So let's just first, what is P? P is everybody over there. Okay. This is P. Let's then shade in green the complement of C. So the complement of C is everything that is not C. So we can shade everything that is not C. Okay, so it does not include the 9, but includes the 8. Okay, you see that? This is green and purple. Now we're ready to get the answer. Intersection means both. It has to meet both requirements. It has to be a student that studies physics and not chemistry. This is where the green and the purple overlaps. It's where I have both green and purple. And there's only one place where that is. That's here where the 8 is. Where there's purple and green. So that means the students that study physics but not chemistry, that is 8. Union, on the other hand, is nicer. That includes everybody and everything, right? Union means all the students that study physics and all the students that doesn't study chemistry. That is everything we've shaded. So whatever we shaded, that counts. That means we take the 8 counts, but we also take the 9 because I've shaded the 9 because they do physics. We include it. And then the 2. Alright, the only place that is not shaded is the 5. So that adds up to, of course, 19. Alright, and that's it. That's the answer. Yeah, 8 and 19. Okay. Note here that there are follow-through marks here. So it means if you got your numbers wrong up here, and then see, whatever you have here, where I got the 8, if you got a 10 there, and you write 10 there, you get your mark. Okay. If I had a 10 and a 5 here, 10 plus 5 is 15, plus 9 is 24, or 24 there, even though that doesn't make sense, you get your marks. Okay. That's the follow-through marks. Then we get to probability. 2 students are picked from the class at random. Okay. Find the probability that the one student studies both subjects. Okay, so this is the first student. There is 24 students to pick from. This one student studies both subjects. Who studies these 9? These 9 in the middle, they study both physics and chemistry. So to pick that student, the probability is 9 out of 24. Then we pick another student, but there's only now 23 students left. Okay, because we already picked one. And one student studies chemistry, but not physics. Basically meaning studies chemistry only. So those are 5. I haven't picked any of those 5 yet. And again, now this is what? What do? We add or we multiply. Remember, the OR rule in probability, we add. Did I pick the one student or the other student? No. We picked the one student and the other one. So we need to multiply this together. Yeah, bro. So let's do that. Okay, but we're not done. We're not done. Alright? Because something else might happen. We might pick this student first. The one that doesn't study, only studies chemistry. So that means it's the 5 out of 24. Yes, 5 students that study chemistry, there's 24 students. And then we pick one of the 9 that studies both, but there's only 23 students left. Well, you note that this is very similar. In fact, these two will give you the same answer. Okay, which we got before. 15 out of 184. Okay. Now we got the OR rule. This or this can happen, so we need to add this together. Or we can just multiply it by 2. And that, ladies and gentlemen, is our final answer. 15 or equivalent. Okay, so that is maybe the hardest part of this one to understand. Now we need to double what we've done. Yeah? Candidates found this challenging, and only a small majority found the correct pair of probabilities. Many did not double the probability. So, it's a tough one, remember that. In this case, there's 2 possible ways to go. You pick the one student and then the other one, or you pick the other student. You have to double your answer. That's a lot to remember. Okay. But you can do it. You can do it. Now, 2 of the students who study physics are picked at random. Find the probability that they both study chemistry. So we're now only looking at the students who study physics. Okay. So now, let's clear all of this. Remember there was 8, 2, and 5. We're only picking from this spot here. Alright. So now, if we pick the first student, there's only 17 we're picking from. Find the probability that both study chemistry. Okay, so there is 9 who study chemistry as well. So it's 9 out of 17. And then Picking the second one, there's only 8 left studying chemistry, and there's only 16 left. Okay, again, so we have to have this and that. So we're going to multiply those two together. Which gives us 9 out of 34. Now the big question I have is, do we double this one again? Right? No, we don't. Don't double this one, because it's the same result. 9 out of 34. Okay. 1 mark for 9 over 17. Because we're picking them from the same pot. Stays the same. Amazing. Question 8. Calculate the area of a triangle. This one is pretty straightforward. Area of a triangle, of course, is half base times height. All we need to do is here half, base being 12, perpendicular height is 9, half of 12 is 6, 6 times 9, 54. Okay, I feel this is maybe just a warm-up for what's to come. Here now we got a different triangle, and we got AB is 2x plus 3, and the height there is x plus 5. So we need to do the same we did before. I'm going to give us the area actually. But this time we need to do with 2x plus 3 and x plus 5. So let's write that. Area of a triangle is half the base, 2x plus 3, perpendicular height x plus 5, and they gave us the answer is 15. Okay, so we need to solve x now, move stuff around. Right, you see that half x, the half in front of the two brackets. We can multiply it into the bracket, get x plus 1.5, but that's going to give us fractions. I've got a better idea. If we multiply everything by 2, or that divide by 2, which is the same as multiply half, if we move it to the other side, multiply by half, we get rid of that half. So it will look like this. So it will be 2x plus 3, x plus 5, multiply the 2, gives us 100. Makes sense? So when we avoid fractions, you can do it with the fractions, of course. I just think this is going to be a bit cleaner. Now we can expand the brackets. 2x times x is 2x squared. 2x times 5 is 10x. 3 times x is 3x. And 3 times 5 is 15. Well, we got an x squared there. Now we have to recognize this is a quadratic equation. So we know that we're probably going to end up with two answers, as it gives us a parabola. There's 2 cos x. Let's just simplify things and move it all to one side. So we got 2x squared, 10x plus 3x is 13x. And then we subtract the 100 there. So it means you've got 15 minus 100 equals 0. Gives us 2x squared plus 13x minus 85 equals 0. Now we can try and factorize this, make 2 brackets like it was before, except we got now the 100 incorporated. But this sentence here is very important. Find the value of x, giving your answer correct to 2 decimal places. So that means our answer has got decimal values, and that will make it very hard to factorize, which means the best option here would be to use the quadratic formula. Yeah? Minus b plus minus square root b squared minus 4ac over 2a. That's it, yeah? Do I remember correctly? We'll find out soon. Okay, so remember now, in this, I have to switch colors, in this equation here, A equals 2, B equals 13, and C is negative 85. So let's put that into the equation. So X equals negative B being 13, positive and negative to give us those two answers. B is 13 squared minus 4A is 2. C negative 85 over 2 times 2. Alright, so this will need to give us two answers, yeah? Two answers. Because we need to do one with the positive, one with the negative. So, here we go. Let's put it in the calculator. Start with the positive one. And we get 4.034 etc. Yeah. Let's just for interest's sake get the other answer, right? So all we need to do to get the other answer, we need to change the plus for a minus. We can use the arrows. We don't have to retype everything. Go back there. Take that plus and minus. Okay, minus 10.5. How did they run the answer? 2 decimal places. 10.53. Okay, but since we're talking about, what are we working out here? We're working out x. Can x be negative? No, x can't be minus 10.5 because that will give us a negative answer, and we're working with a 2D shape. In reality, it can't be negative. So we're looking at the positive answer here. Very important. Give your answer correct to 2 decimal places. So we have to write it correctly on the line. Cut it off there, 4.03. And there we go. 4.03, correct answer only, means you can't put anything else. Okay. Lots of marks to pick up here. Just getting this part here gives you 3 marks. So let's go through the marks here. You can see where to pick up marks. You get a mark for writing the equation correctly. You get a mark for expanding the brackets correctly. And you get a mark for simplifying correctly. You get 2 marks for using the quadratic formula correctly, and then a correct mark for the final answer. Lots of marks to pick up there. Easy as pie. You can do it. Question 9. We got the function x cubed minus 3x squared minus 4. So what you need to remember, alright, is what a cubic graph will always look like. Huh? It's got 2 turning points. Alright. Having the minus 4 there probably means it will go through minus 4 on the y-axis. But that's all I can tell from it now. Exactly what it looks like, I can't say yet. It tells us to find the gradient where x equals 1. So the moment we're working with the gradient, we need to differentiate. Differentiate dy over dx. Okay, so finding the gradient on any curve, you need differentiation. So let's see if you remember how to do this. Imagine there's a 1 there. You do 3 times 1 is 3. X, subtract 1 from that 3, that gives you 2. Then you do 2 times minus 3 is minus 6. X, subtract 1 from that 2, that gives you 1. Anything to the power of 1 is the same, so we don't have to put the 1. You can think this as x to the power of 0. 0 times minus 4 is 0. And that just cancels. So when it's a number, it cancels away. There we have differentiated. Okay, we want to know the gradient when x is 1. So all we need to do then is substitute 1 into x. That will give us 1 squared is 1, 1 times 3 is 3, minus 6 times 1 is minus 6. Answer, minus 3. So the gradient at that point, minus 3, which is negative, which means it goes down. Okay, so if we're going to want to revise our graph, we know that if this is 1, where x is 1, we know the graph is going to be on a downward curve there. Okay, going through minus 4. Something like that. So it could probably be like this. Who knows? We'll see. We'll see. Right. Find the coordinates of the turning points of the graph. So the turning points would be like where the graph turns. There and there. Yeah? Okay. What happens at those points? Well, the gradient is 0 because that's where it goes flat. Gradient is 0. So again, we need to differentiate, which we've already done. So we're just going to copy that. Okay. Which was 3x squared minus 6x. We've already done that. But now we know what the gradient is. We want to know where it is. The gradient will be 0. So that's equal to 0. And we need to solve this. So solving this, we know there's going to be 2 turning points. We need to factorize. So common factor of 3 and 6 being 3. And then both these terms has got an x. So we factorize out an x. What is left then is an x in the bracket, because 3x times x is 3x squared. And a minus 2, because 3x times minus 2 is minus 6x. So we check that if you expand the brackets, you get the same thing. Now we can split up into our two answers. We can say 3x equals 0. That means x equals 0 divided by 3, which is 0. So the one turning point will be where x is 0. So again, let's revise this. Okay, it's going to turn where x is 0. Yeah, let us just find the other turning point. That will be x minus 2 equals 0. So x equals 2. And then where x equals 2 will be the other turning point. Right, so we got two x values, 0 and 2. What is the y value, since we want the coordinates, yeah? Remember, this is the x, we worked it out. Now we want to know what is y. Where will I find the y? Well, there's a y. And that's the same y as, well, y equals the function of x. So that means we can also write this, the function of it, that's a y. Y equals all of that, because y equals function of x. If you want to find y, we need to substitute it into the equation of the original one, not the differentiated one, yeah? So what was that? X cubed minus 3x squared minus 4. First one, 0, that's easy. 0 cubed is 0 minus 3. 0 squared is 0. 0 times minus 3 is 0, so what will be left is minus 4. So when x is 0, y is minus 4. Let's do the same now for x equals 2. So that will be 2 cubed minus 3. 2 squared minus 4. Alright, what will be the 8 minus 12 minus 4? Okay, don't waste your time. Just get the calculator. Do it quickly. 2 cubed minus 3. 2 squared minus 4. Y is minus 8. There we go. Minus 4 to minus 8. Okay. Show all you're working out. Now it tells us to sketch the graph. Okay, so like I said, that value at the end, the minus 4, okay, is where we know it will cross. Let's just do this in pencil, you know. It will cross the y-axis at minus 4. We also know that that is a turning point, like it's shown here. Okay, so this point, 0 minus 4, let's write it, 0 minus 4 is where the graph turns. So it must be coming up and then turns. Remember, positive cubic graph always comes up from the left. Got a negative in front, it's coming down. Okay, so that's a turning point. We know that where x equals 1, it's got a negative gradient. So that's where it goes down. So that makes sense. Alright, so if this is 1, then the graph is going down. Just needs to look neat. Okay, it's going down. And then the next turning point is a 2 minus 8. So imagine if 2 is here and minus 8 is here, then it turns and goes up again. So this will be the point 2 minus 8. Something like that. Yeah, there we go. Okay, so basically if you have any graph looks like that, yeah, doesn't matter if it's the correct place, it's going up, down, up, 2 turning points, that's 1 mark. And if the turning point is on the line y-axis there and the right quadrant, just has to be in the 4th quadrant here, you get your 2nd mark. Okay, 1st mark easy to get, 2nd mark a little bit harder, you know you can do it. Question 10, and there we got a bunch of triangles, which means trigonometry. Alright, remember the following with trigonometry. If you have a right angle triangle and you're working with just the sides, no angles, except that you know one of them is 90 degrees, we use Pythagoras. If we're working with a right angle triangle and there's a side and an angle involved, you want to know the angle, you want to work out the angle, you want to use the angle to work out a side, that's when we use SOH CAH TOA. Alright, if we got a triangle that's not a right angle triangle, where are we going to do this to make it a bit bigger? Okay, like we got a triangle, not right angle triangle, and we got 2 sides and an angle in between. We got it, or we want to know it. Okay, we want to know the angle, 2 sides in between, or we are working, we've got all the sides, we want to know an angle, right? That's when you use the cosine rule, which we'll write down later. If you got an triangle that's not a right angle triangle, and you have an angle and an opposite side, that's all you need to look for. You've got an angle on the opposite side, okay, and you want to work out another angle, another side, but you got that angle, opposite side, that's when you use the sine rule. You can remember those 4 things, you're well away of sorting out the trigonometry, right? So, let's see what that translates into. We got this diagram, it's a quadrilateral, and then inside the quadrilateral there's a bunch of triangles. We got AC is 12.3, AD is 16.5. They pretty much just tell us what's in the diagram, give us some angles there, 31. Tell us that we've got 2 right angle triangles, Pythagoras, SOH CAH TOA, and then they started to working out stuff. First one, show that AB is 10.54. So let's highlight that. Now we're going to use colors today. Let's start with an orange. Okay, AB, we need to work out AB. Well, we know what's the answer. Okay, so first So what is AB? AB is part of this right angle triangle. Okay. It's also part of another triangle, but let's go with the right angle triangles first. And in this right angle triangle, we've got two pieces of information. We've got the hypotenuse opposite the right angle is 12.3, and we got an angle. So what did I say? Angle involved, SOH CAH TOA. So we know we're going to be using SOH CAH TOA because we got a right angle triangle and we got an angle involved there. Let's label the sides of this triangle. Okay, just like I said, opposite the right angle, we know that is the hypotenuse, the H. And then we got the angle here, and right next to the angle we want to know the side, so we're going to use the adjacent. Okay, and the opposite is not at play here because we don't have it and we don't want to know it at this stage. Okay, maybe later. So working with the hypotenuse and the adjacent, the A and the H, we know we're going to use cos. So we start by writing down cos. And after the trig ratio, always first comes the angle. So cos 31 degrees equals, A is third, that's the adjacent, that's the one we want to know. So we call that AB over the hypotenuse 12.3. So we want to know what is AB. We need to get rid of that 12.3. We simply multiply it on the other side. So it will be 12.3 times cos 31 degrees give us AB. Now we just hold fingers that we get 10.54. Okay, let's do that. 12.3 times cos 31. Excellent. Now very important, right? We're not finished. You write AB equals, okay, write a bunch of digits, 10.5431, yeah, etc. That will round to 10.54. Because yeah, just writing on 10.54, they already told us that's the answer. We need to show that it rounds to 10.54. So we need to write more than 2 decimal places and then round it. Okay. So where is it? There we go. There we go. See? Very important. You write down your trig ratio, that's 1 mark, and then the unrounded answer gets you that 2nd mark. So it's important, yeah? It's really important. You write down the trig ratio, and this is the one you get the mark for, and then you round it. Sweet. Right, let's jump to this funny color. Show that the angle DAC is that corrected 2 decimal places. Alright, so angle DAC. Let's clear the clutter. Okay. Angle DAC. So we're not talking about this angle here. We want to know what is that angle. Alright, again, it forms part of a right angle triangle. Okay. Again, there's an angle involved. Yeah, we want to know what the angle is in this case. Still, angle is involved, so we're going to use SOH CAH TOA. Let's label the sides, right? The right angle is over there, so opposite that, 16.5, that is the hypotenuse. Next to the angle is 12.3, and now this will be the adjacent. It's changed for this triangle. Before that was the hypotenuse change. Again, the opposite, we don't have it, or we don't want to know it, so it's not involved. Okay, so it seems we're going to use the same ratio. Yeah? The A and the H, again, we're going to use CAH. What a repetition. Okay. Now, we need to work out angle DAC, so we need to start by writing cos and then the angle, which we don't know, so I'm going to call it DAC, equals, again, the adjacent is at the top, so that's 12.3, over the hypotenuse, 16.5. So now we want to know what DAC is. We need to move that cos. Inverse of course, power of minus 1, 12.3 over 16.4. I think that's what they're checking this time. If you can do the inverse. So whip out our calculator. We need to put shift cos and then 12.3 over 16.5. Side arrow. Bam. Again, show more than 2 decimal places. 41.8018. That will round to 41.80. Okay, so we know it's right. Again, 1 mark for showing that trig ratio, yeah, and then 1 mark for showing the unrounded answer. Very important. So far, so good. Okay, you can guess what's coming next. Pythagoras, cosine rule, sine rule needs to come up. Okay. Question C, calculate BD. Let's clear the clutter. Okay, let's just write in the information that they gave us, yeah? We have AB is 10.54. We might need it later, especially if they give you the answer. And this one was 41.80. 41.8 is good enough. Alright, so now we're doing BD. BD. Shall we go for pink? BD. Okay, now BD is not part of any right angle triangles. BD forms part of this triangle here. Okay. So remember what I said, yeah? Do we have an angle? Have an angle on the opposite side, right? No. We want to know this one. We've got 16.5 and 10.54, and we got an angle here. We add them together, 72.8. So 2 sides and the angle in between, like I mentioned here. So we're going to be using the cosine rule. Now remember, there are 2 versions of the cosine rule. If you want to work out a side, we use the first basic one, which is easy to remember because it's a squared equals b squared plus c squared, just like Pythagoras. Then minus 2bc cos a. Memorize that. So what is what here? What is what? What is what? What is what? Okay. In this case, the a will be the a. So that's sweet. We leave it just like that. B and C doesn't matter. Okay. There's a B here, so we can make this a little b and a little c. But if we swap those 2 around, it's not going to matter. B and C is simply the 2 sides that encloses the angle in any order. Okay. So now we can start substituting stuff. Okay. So what we refer to as A, that is BD, what we want to work out. Okay, so we'll write this BD equals, then like I said, B, we made that 16.5, but if you swap it around, it doesn't matter. C, 10.54, the other side that you didn't use. Then we repeat those 2 again in any order. Cos, and then the angle, which is this whole one, 72.8. Now before I continue, I'd like to do something here. You see we got this square here. I like to get rid of it at this stage. Say, right, I need to do this anyway later on, so I might as well do it all at once. Square root everything, so then we'll be sorted. So instead of working out everything and then square rooting it, oh my goodness. Right, so here we go. Square root. Big drum roll. 14.8. There we go. Big drum roll, because I got that one wrong. 16.7. Just how easy it is to type the wrong thing. 16.7. 477. Rounded to 3 significant figures. Cut it off there. There's a 4. It stays the same. 16.7. You see when I typed it wrong, I didn't type that number correctly and get the wrong answer. This time I got the right answer. Okay. 16.7. See, they are very lenient here with the rounding. So there's a few options. Even the unrounded answer is good. Okay. So there are a few options here to get full marks. Basically, I will get 2 marks for this. And if I made that calculation mistake, then I would have lost 1 mark. But I got the mark scheme and I changed it. And now it's correct. 16.7. Nice. Okay, next, calculate angle CBD. So let's clear this clutter. Angle CBD, and that is this angle here. Okay. Now, how are we gonna do that? My plan is, I think this is what I'm gonna do. I'm gonna use this triangle here to work out this angle. And then because this is 90, I can subtract that angle and then I'll have the angle we want to know. Alright, do that because I've got some information. I know this side, we just worked it out, is 16.7. Alright, so now I've got that. I've got the angle and the opposite side. The moment you have an angle on the opposite side, you can use the sine rule. Okay, use the sine rule and that side there to work out this angle ABD. Okay. Sine rule's got 2 versions. The best thing is to put at the top what you want to know. I want to know angle ABD. So we write that first down, right? Sine ABD over the opposite side, 16.5. Okay. If I wanted to know the side, we can put the sin at the bottom and the side at the top. Right, then we write the other angle we have. So again, sin at the top. The angle we have is this one, 72.8. Over the opposite side, we worked it out, 16.7. So to find an angle, we need to do a little bit of rearranging. First, we will multiply the 16.5 there. So it will be 16.5 times sin 72/8 over 16.7. You can write that 16.5 in front as well. You don't have to write it at the top, as long as you multiply it. And then, of course, if we're going to find that angle, we need to move the sin there. So it will be sin minus 1, 16.5 sin 72.8 over 16.7. Let's hammer that in our calculators. Do it slowly, so make sure you don't make any mistakes. 70.706. So ABD is 70.706, etc. Now remember what I said. This is not the angle we want to know. We want to know that angle over there. So we need to subtract it from 90. So we need to do 90 minus 90 minus, insert the previous answer, 19.29, etc. Okay, round it to 3 significant figures, or rather this is an angle, no? So 1 decimal place. Okay, there's a 9, so we need to round it up, 19.3 degrees. So 19.3 is in that, they're quite lenient with this one, right? Quite open here. So mine is correct. Definitely get my marks. Okay, it's just one thing I noticed they used a different method here. They worked out BC, they worked out CD, and then they used the cos rule in a different method. Okay, so if you use a different method and you got your answer within that range, it's correct. Okay, I'm not going to go through every way. That's what happens with trigonometry. Once you get to the harder questions, there tends to become more than one way to do them. I've only done one way. Okay, well, I got it right. Maybe you got another way. You definitely will have another way to do it. Okay. Calculate the shortest distance from C to BD. Now I remember them mentioning this one. This is question 9. What are we on? Question 10E. Right, this was apparently a difficult question. Okay, and they asked the questions quite a lot. Okay, so let's clear the clutter and let's see what we can figure out. Okay, they want us to find the shortest distance. It's just from C to the line BD. Remember, the shortest distance is always going to form a 90-degree angle. So if you want to make this distance shorter, it's going to have to be straight at a right angle. That doesn't look like a right angle, does it? Okay, so that will be the shortest distance. You see, and we'll form a right angle triangle over here. Okay, that will be the shortest distance, and that's what they want to know. Okay, let's call it X, because I don't have a name there for that point. They give us a name. Yeah, so from C, C is a point, BD is a line. Shortest distance from C, the point, to BD, that line, will form a 90-degree angle there. Okay, that's what they meant. That's maybe what people struggle to understand. Okay. What information do we have here? Not much. Okay, we know this angle, we just worked it out, and my answer was 19.3. So I'm going to use that. We got this angle here, 19.3. Okay, is there anything else I can find out? Yes. I can and I will. Okay. Let's use the right color. In this triangle here, right angle triangle, I got a lot of information. Got one angle and two sides. Okay, I can use the sin rule because I got a 90-degree angle the opposite side. I can use SOH CAH TOA because I got an angle and a side. What I'm going to do, I'm going to use Pythagoras. Okay, I'm going to use this and this Pythagoras to find out this side here called BC. Alright, so let's just write out the Pythagoras rule for this one. It's the hypotenuse, AC squared. This is just one of many ways, alright, so AC squared equals BC squared plus AB squared. Because we know what BC is, we're going to rearrange it, yeah? We're going to move the AB there. I'm just going to write this way around, so it's AC squared minus AB squared equals BC squared. Meaning, if we want to find the length of that one, we need to square root. Okay, so remember, when you're using Pythagoras and you work out something that's not the hypotenuse, you always subtract. Okay, and you subtract from the hypotenuse. So BC will be, what's AC again? 12.3 minus 10.54 squared. So let's put that in. Right, don't round this, 6.34022. Lots of digits, means our answer stays accurate. Okay, so we now know this is 6.34022, etc. Again, we got a right angle triangle. Let's go back here. Okay. And this is the one we just worked out, is the hypotenuse. Okay. And we got this angle here. This would be the adjacent, which we are not using at this stage, and we don't want to know. And x, the one I want to know, is the opposite. So it's H and O. So using SOH CAH TOA, we're using H and O, hypotenuse and opposite, so it's going to be sin. That angle, 19.3. Then we need to put the opposite, is the one we don't know, and the hypotenuse is the one we just worked out. So to find x, multiply that on the other side. Whew. We're getting to the end of this. Let's open it up. So I still got that there. I just need to put times sin 19.3 2.0955. So x is 2.0955, etc. Three significant figures means we cut it off there. That gives me, that's a 5. Round up the 9 becomes 10. So 2.10 is my answer, which is in that range. Good. Between 2.05 and 2.24. Again, because there's so many ways to do this question. All right, I see they used the sine rule here as well, but they did sine 31 to work out BC. Yeah, they did that part the same. They worked out CD. Yeah, I think they kind of used the same method I did. Okay, but there will be other ways to do it. Like we can spend all day finding all the ways they've done it. As long as you show you're working out. Okay, remember your answer is within that range. You might have a different answer from me. It needs to be in that range. Not from wrong working means it's very important you show you're working out. You can do it. On to question 11, functions. We're still going strong. We're going to do this. All right. First one, find function of j with a minus 1 in it. So we just need to take the function of j. Yeah, and put a minus 1 where the x is. I think the only thing you want to check here is here. Do you know? You need to put in brackets here. Minus 1 times minus 1 is 1. That's it. Well, that's all to it. You need to have a 1 You have a 1. Where is it? There. 1. Okay. Next one. The function of f, which is 2x minus 1. Then the function of g, which is 3x plus 2. We have to add them together, and that is equal to 0. Collecting like terms, 2x plus 3x being 5x. Minus 1 plus 2, or 2 minus 1, it gives us 1. Now we just need to solve, subtract 1 from both sides, subtract the 1 from the other side, becomes negative, and then we divide the 5. And that's it, negative 1 over 5, right? You've got the minus at the top, doesn't matter, okay? Or the minus at the bottom, or the minus in front, or as a decimal, they're all correct. Next one, the function g, 3x plus 2. And then there where the x's, we need to put the function g. So we put g into g. Expand the brackets. 3 times 3x is 9x. 3 times 2 is 6. There's a plus 2 hanging around at the end. Added to the 6, we got 9x plus 8. So far, so good. Reading in the answers. Okay. Bam, here comes D. What do they say about D? Again, more challenging. Okay, we can do it. We can sort it. We'll do it. Right, so first we're going to take the function h. What is that? 1 over x. That's the function h. And then where the x is, we're going to put the function f, which is 2x minus 1. Okay, so instead of x, we put 2x minus 1. Okay, plus, then we take the function g, which is 3x plus 2. And where the x is, we're going to put h. So instead of x, we put h, that's 1 over x. So instead of that, we put 1 over x in brackets. This is important. I think that was the easy part. Because now we need to write it as a single fraction in its simplest form. My goodness. I'm going to do this real slow. I'm going to leave that first one the same. Multiply the 3. Remember, when you multiply a whole number with a fraction, you just multiply with the top. So it will be 3 over x with a 2. I'm going to put it over 1 because we're dealing with fractions here. Now, we need to get a common denominator, alright? So what I'm going to first add the last two fractions just to keep things simple, right? So let me just explain this quickly. If we're adding two fractions together, there's a quick way to do this. We call the smiley face method. We need to get the common denominator, in which in case this state will be 6. So we can get it by just multiplying those two together. Then we can multiply that 3 there and that 2 there. So multiply across, and that gives you the answer 5 over 6. Okay, this is like a shortcut. Nice way to do this. Okay, which is the right answer. Half plus a third is 5, 6. So we're going to do the same. We're going to multiply the two denominators together and multiply across. Yeah, you got that? So leaving the first fraction where it is, multiply these two together. So x times 1 is x. Multiply the 1 with the 3. Multiply the x with the 2. Now we've reduced 3 fractions, 2 fractions. Next step, do the same with what we got, right? So again, we multiply these 2 fractions together. That will give us x times 2x minus 1. Yeah? Multiply this x with the 1. 1 times x is x. There's a plus in the middle. And then we multiply this there, which is 2x minus 1 times what's at the top. I'm just going to swap this around because we can. Just 3 plus 2x is the same as 2x plus 3. It's just easier when we expand the brackets. Looking good so far. So the next step, which we'll do up here, okay, the denominator, we're going to leave it like that. We don't have to expand it. We can for fun if you like it, but expand these brackets. Okay, the x there still hanging around in the front. We're going to do 2x times 2x, of course, is 4x squared. 2x times 3 is 6x. Minus 1 times 2x is minus 2x. And minus 1 times 3 is minus 3. Next, collect like terms. So we use the highest power first, 4x squared, it stays the same. 6x minus 2x, that adds up to 4x. And then we add to that 4x the x over here, which gives us 5x. Minus 3 is hanging around the back. Can we factorize this? No. I think that is the final answer. Sometimes you can factorize it and cancel it with something below. Okay, like I said, harder question. We got it right. Lots of marks to pick up there, yeah. So you look at that. 1 mark there, 1 mark for getting the common denominator, 1 mark for expanding the brackets, and then for simplifying. You can do it. Right, then we got E, which is a little weird question I'm looking at here. When ppx equals x, which one of those are we going to try? When we put the one function into the other one, we need to get x. Cool, let's do it with the first one, alright? Haven't we done that already? ffx. So we did ggx, you see? And we didn't get x, we got 9x plus 8. So, very unlikely it's one of these. Let's try this one, this jx. Let's try jx. It means we write down the function of j, and then instead of x, we put the function of j again, in brackets. So, what's the power to power? You multiply them together, that's x to the power 4. It's not x, like they say there. You know where this is going, you know where this is going. Let's try hx. Means we take the function of h, and then instead of x, we put the function of x again. How would you simplify that? You can think of it like this. I've got 1, which I'm dividing by 1 over x. Now remember, when we divide with fractions, we invert and multiply. X divided by 1 is x, x times 1 is x. Beautiful, you see? That gives us x. hx gives us x. So for this first part here, the answer must be this answer. Okay, but then they go and continue more stuff. They say the inverse of px equals px. Alright, so remember how to get the inverse. One way to do that is to take the function, let's take h, and set it equal to y. Then we need to make x the subject. So first thing I'll do, I'll multiply x over there. That gives me xy equals 1. Then to get x alone, we divide the y over there. So x equals 1 over y. So when we write the inverse of x, we need to take this answer here, but just put an x back. See? Same thing. The inverse is equal. Hope that makes sense. Shows us why that is the correct answer. hx indicated. Yeah, they always throw a weird one in with the functions, don't they? We have made it to the last question. What a marathon. Okay, if you're like me, your brain is a little bit of juice, can't remember nothing. But I'm going to show you a few tricks to sort this out. We need to draw the sketch of the ton graph. Now, if you remember what it looks like, you draw it very quickly. Great for you. Smart man. Okay. If not, there's always very easy ways to find out, to refresh in your mind, right? We want to know what is tan 0. If we put tan 0 in, we get 0. So we know if the angle is 0 for tan, the answer is 0. So we'll go through the point 0. Okay. Let's try tan 90. So let's change that for a 90. And we get a maths error. So I mean, the tan graph is not going through 90 degrees. That means this is an asymptote, yeah? It's when it doesn't touch. Tan 90 doesn't exist. Okay, exactly why? I'm not going to go now. I mean, we're at the end of the paper. But we can do other stuff, like we can do what is tan 45? Oh, that is 1. So let's imagine if this is 1, then we know that this graph is going to go through that point there. Okay, let's continue this. Let's see what is tan 180. Okay, 180, again, that's 0. So we know it's going through this point here. Let's try halfway here. What's halfway between 90 and 180 is 135. So what is tan 135? No, I did something wrong. 2 brackets. There we go, minus 1. So minus 1 is down here. We know the graph is going to go there. Okay. So we know it's going there, there, there. Do you start remembering what a tan graph looks like? Let's try tan, what's another? 225. 225, guess we get a 1. So halfway here it gives us 1. Tan 270, remember what I'll give you? Okay. You can play around like this. Again, maths error, right? So that might help refresh in your mind what the tan graph looks like. It goes something like this. Okay, where we have the graph going up, approaching the 90-degree angle but never touching it. Okay, and the same here, going something like that. Remember now? Okay, if you're not sure about this, go study again. Okay, but putting into a calculator helps us. Remember, 270 was also asymptote. So make sure you don't touch the 90 and the 270, and got those curves right. Okay. Alright. So don't touch the asymptotes. Don't cross them. Okay, but that's the kind of the shape you want to get full marks here. Study it. But if you forget, use your calculator to help you. Next one, we need to find x when tan x equals 1 over square root 3. What is 1 over square root 3? Let's have a look. 1 over square root 3. There, 0.577. Okay. 0.577 is like, if I said, if that's 1, 0.577 would be around there. Okay, that 5 doesn't look like a 5. So if I were to go across here, what is the angle we'll find there? That's the question. Okay, what is tan x equals, gives us 0.557. To work that out, we can just move the tan to the other side and do the inverse of tan. Okay, so we can put that in our calculator. So let's do that. Let's put the inverse of tan, close the bracket, bam, 30 degrees. That means when tan 30 degrees, it will give us 0.577 using my graph. Yeah, does that make sense? So that means x equals 30 degrees because tan 30 degrees equals square root 3, which is 0.577, or 1 over square root 3. Different way to write it. Okay, but that's not the whole story, because they say you need to find all the answers between 0 and 360, and if we were to continue along here from 0.577, we will cross the graph again and go down. What is that angle there? Now, because the whole graph thing is very symmetrical, if this distance from here to there is 30, this distance from here to there would also be 30. So 180 plus 30 is 210. Is that right? Is that right? Is that right? Let's check. Okay. What is tan 210? Bam. Same thing. 0.577. Okay. So that means x can also be 210. Okay. Or you can remember the rules for the sin, cos, tan graphs, and you always, to get the two answers for tan, you just add 180. That's another way of understanding this. Anyway, got our two answers there. You need to have both to get full marks, and that will check in. Remember, there's always two answers. And now you've done it. You've done all of it. You're gonna do great. Well done.